right, ladies and gentlemen, hello and welcome back once again. It's time for DM Radio. Yes, indeed, my name is Eric Kavanaugh. I will be your host for the show that is designed, after all, to peel away the marketing veneer, get down to brass tacks, and figure out what is going on in the world of data. Goodness gracious, when I got into this business about 15 years ago, data was important. People understood it. Companies spent a lot of money on things like data warehouses. Companies made a lot of money selling database technologies. Companies like Oracle and IBM and Teradata, these guys really did very well for themselves and built a whole industry that grew into the business intelligence industry, as we called it. And then in the last few years, things have really taken a whole new turn, and that turn can be best described with the word scale. So when you start talking about data at web scale, you're talking about a whole lot of data. And frankly, it's so much that it just crashes the old systems. And so what happened is the big .com companies of the last 10 years or so, and I'm thinking specifically of a company called Yahoo that many of you may know about, they invented new technologies for handling this stuff. And we've talked about this on the show a couple of times. Some of you may recall there is a concept called Hadoop. It's spelled Hadoop. That spun out of Yahoo, and it was basically a way to index the web. So if you think about how Yahoo and Google are able to provide search of the internet, well, it's through directories that they create indices basically by scanning the web. And Hadoop, and we have one of the folks on the show today, I'm very excited, who was at the epicenter of that whole movement 15 or so years ago, or 10 years ago at least, Usama Fayyad. He was there, and he can talk a little bit about the history of Yahoo and kind of what happened there, because it's actually a really, really big deal, and it wound up injecting a tremendous amount of energy and enthusiasm into the open source movement. So open source, as many of you know, is a movement in software development where you design the code, but you make the code, the source code that creates the application, open for the public. So sites like GitHub, for example, store all this code. And it's been quite a revolution over the last 5 to 10 years or so, where things are really changing dramatically. And then in just the last few years, we've had other big web players, like Facebook, for example, spin out Cassandra, a database. Or we had LinkedIn spin out Kafka, which is the messaging system that runs LinkedIn. So what's happened is there's been this whole transformation in how companies design code. And open source is largely the new normal. There are still major vendors that are very tight-lipped and still do the closed source route. That's still out there. But open source has definitely changed things. And to that end, some other big developments have come across in the last few years. One of them is called DevOps. Those of you who work with your IT team in a business or are part of the IT team have probably heard that term. It refers to development operations. And what happened is developers started working directly with business people who are running the operations of the organization. So DevOps really transformed how quickly companies can adjust and align to market needs. A lot of times it has to do with customer-facing applications, like web-based applications, for example, where DevOps might come in and fix some problem that's causing a disruption in sales. Of course, you think of the big poster child these days who's really just rewriting how business gets done, and that's Amazon. And Amazon isn't just good for moving books or buying grocery stores. Amazon Web Services is an absolute juggernaut in the software provisioning space. So Amazon Web Services was really kind of a creeping giant for a long time, and they got a 10-year head start in terms of cloud. They have just done amazing things, and now finally we have Microsoft and IBM and some of these other players, even SAP, rolling out their own cloud offerings, as everyone has kind of figured out that cloud is the next big thing, and it really, truly is. So cloud is where the future data gravity is going to be. And I'm saying all this as sort of a lead up to the topic for our show today, which is data engineers and the rise of data ops. So this is a term I only actually heard last year and then earlier this year. And we have one of the guests on the show today who, for me, is the pioneer in this space, really. There are a couple companies doing this data ops stuff, but it's kind of like the complement to the DevOps. So if DevOps is for development operations, folks working together, data ops is really focused on trying to formalize and fine-tune and really harmonize the whole data life cycle. So where data gets pulled from, how it gets ingested, how it gets cleansed, for example. Data quality is always a big issue out there for people. these are all issues to be addressed. So data ops is really fine tuning that production line, if you will, for data, and it's changing things. So one of the challenges with using data for insights and to run businesses is the fact that data comes from a lot of different sources. I mentioned in our pre-call with our guests before we went live here, the company Teradata, which has been the 800-pound gorilla in the data warehousing space for years, well, they're going through a transformation now, in part because of this whole open source movement. Well, Teradata was the master of the data warehouse, and the data warehouse is where you would pull data from all these different source systems like enterprise resource planning systems, customer relationship management systems, any kind of ordering systems that you may have. You pull that all into a warehouse so you can analyze it. Well, now, these days, the trend is to kind of hopefully leave data where it is, not move it around so much and do federated queries across all those systems. So things are really changing and changing dramatically. But that data warehousing movement is now in a bit of a turbulent situation, as there are other ways of getting the job done. So the point is that data ops, if done properly, and data engineers, as the people who help in this process, can really assist organizations in dotting their I's and crossing their T's and making sure that they're treating data appropriately. And, frankly, there are some major regulations coming down the pike, like GDPR. Some of you may have heard about this, the Global Data Protection Regulation of the EU. Things like the right to be forgotten are also forcing organizations to take this all very, very seriously. So my point is that data ops is a thing. It's a big thing. It's going to be around, I would argue, probably forever. And we're going to talk about that today. So with that, let me bring in Chris Bergh of DataKitchen. He's the guy who first elucidated me about data ops. Welcome to DM Radio.
Thank you for having me.
Sure thing. So why don't you tell us about DataKitchen, first of all, where the idea came from, and how you realized in the whole hero's journey concept that you have that data ops was something that needed to happen.
Well, I've been in the analytics field for a while, and it used to be a nice corner of nerddom where, people thought, oh, what do you do analytics? Is that a chart or a graph? And now you can't walk through an airport or pick up a magazine with people not trying to be a data-driven company or do analytics. And so my journey sort of parallels that. And I managed teams of people who did what's called data science. They did algorithms. They're kind of the mad scientists of the data work. I also manage people who we call data engineers, and they're sort of the ones that carry the lunch pail and did the heavy lifting, and also the people who did visualizations, and they're sort of the artists of the field. And you've got these teams of people, the artists, the mad scientists, the people who carry the lunch pail, who are all working hard to deliver value and deliver insight. And the challenge that they face is that they've got these two things going on that are really simultaneous challenges. One is they really are doing a production line, like Toyota puts out cars every minute. People who are doing analytics are integrating data, building visualizations, updating models all the time. And that production line has to run and smooth and deliver quality, or else that whole team looks bad. On the other hand, they're actually an idea organization. They're trying to, just like software developers, pull and create value out of the data that they have at hand or find new data. And then they've got to put those things back into production. So there's these interesting group of people, and they're trying to do these things that are really opposite of each other. They're trying to run a factory, and they're trying to actually rebuild the factory as it's running. And that's just a hard task to do. And what really the hero's journey comes is that there are, in my experience, you can do it as a hero. You can try to do everything yourself and be the cool tech guy who gets it all done, but that gets old after a while. And what you realize is that it's about the team. How do you make the team successful? And those things that people learned when they ran factories, like industrial process control, statistical process control, demming play, and making that happen. And so my hero's journey is just realizing the operational side of analytics is really important, and data ops and DataKitchen, we're trying to lead the movement on making that happen.
Yeah, and I really like this concept that you have about the hero's journey and don't be the hero, basically, because it speaks to the fact that there are many people in the business world who, through no fault of their own, really, just don't fully understand how much hard work goes into getting a nice dashboard. What all the hard work is of finding the data, setting up the ingest, making sure that's working properly. Of course, ETL is still a massive force in the industry, extract, transform, load. really basic nuts and bolts stuff, plumbing essentially, but a lot of folks on the business side just don't know how much work that takes. And when they appreciate the amount of effort that goes into these initiatives, I think that creates a better dynamic in the business and a better relationship between the data engineers and the business people, right?
Yeah, and should they really understand? I mean, the business people can get a package delivered from China overnight, and why can't they get a customer segmentation on their dashboard the next day? They don't understand it, and technology has weird discontinuities where some things are quick and some things are slow, and they don't understand that. And the people who are in charge of these analytic teams are really, in some ways, kind of getting beaten up by their business customers because they can't deliver things quickly. And they've got to corral not only the people who do the data, but the data scientists and the artists to put together this change in the dashboard. And so I think that's a challenge that our industry has to work on. Just like Chevy was challenged by Japanese manufacturers by making cars that were frankly higher quality and better in the 80s. And it used to be, as a software development manager, which I was in the 90s, if you could ship software every 3 months, you were pretty cool. Now you can't even get a job shipping software every 3 months. You have to be able to ship software every 3 minutes or every 3 seconds. And so the cycle time, the amount of quality, those things that you talk about in an auto manufacturing concept have gone from manufacturing to software development and now entering the world of data analytics.
Yeah, and I think that the reason why we're seeing all this activity now is because of that whole reality of scale, right? Of the fact that you have all of these internet-born businesses that are fundamentally changing how things get done. And I mentioned Amazon as the poster child. Because the cloud democratizes both data and functionality, now anyone who wants to compete in the real world needs to understand there are certain table stakes, and if you're going to be playing with the big boys, you have to adhere to some of these new rules and these new policies and these new ways of doing business, right?
Oh, absolutely. And I think there's a lot of companies who viewed data as kind of dirt, just something that happened that you stepped on. And what they've realized is that data is kind of soil that you can plant value for growth in. And so the idea of being a data-driven company as using data to make decisions is I think everyone for the 10, 15, 20 years ago would have agreed that they do that. But what that really means and how you build an organization to take that soil of data and grow interesting things on it year in and year out, that's something that people are challenged with. And some companies are better and some companies are worse.
Yeah, so let's talk about what they actually get, what your clients actually get. I've actually seen the software that you guys use. It's very interesting stuff, and it's really an environment. You call it a kitchen, but it offers functionality for the different component parts of the process, right? Like pulling data in, doing the testing, the QA kind of stuff. Can you walk us through just like the 4 component parts that you deliver?
Yeah. And well, I guess we first start with the perspective that there are people who the data scientists, the data artisans, the lunch pail carrying data engineers who all love their favorite tool to do their work. And there's just a multi-billion-dollar industry creating their different tools. And so we believe that those tools should fundamentally plug into a platform that allows them to be able to go fast, orchestrate all those tools, and kind of run that production line with all their tools being plugged in. And then the second thing that our tools should do is be able to take sort of a copy of that production line, and you mentioned that the cloud makes it easier to do that, and kind of run their own little place, their own little version of that production line so they can play around and invent, because it is an ideas business. And then finally, they should be able to sort of press a button and take what they've invented and sort of deploy it quickly into production. So when that VP of marketing asks for a customer segmentation, they can deploy it in production with sort of high confidence, because no one really wants to be a hero, and no one wants to be on the other side of that dichotomy either, kind of living in fear. And so you shouldn't have to choose either the left or the right. You shouldn't have to be a fearful data engineer, data scientist, or you shouldn't have to be the hero. You should be able to deploy quickly with high quality and sort of, go home and wake up Saturday morning and have your coffee and not have to field phone calls and then get dirty looks from your wife.
No, I really like that part of your story, because I think you're speaking to a very significant reality in the business world, especially vis-a-vis data. Because again, there's a lot of work that goes into getting data prepared, getting dashboards prepared, getting OLAP cubes prepared, for example, online analytical processing. There's a lot of work that goes into that stuff, and it's, a lot of it is fairly tedious stuff as well. And hitherto, there was a lot of opacity in terms of how that all got done. And for all kinds of reasons, you don't want that. If you're a business person, especially in a regulated industry, you want transparency into where the data came from, how did somebody change it, who touched that data. And here again is one of the cool aspects of the cloud, because a lot of the processes like metadata management, for example, are just baked into cloud offerings, and you can see it now. Like I use a lot of email marketing applications like iContact and Constant Contact, and you can see who loaded which file of contacts on which date, where did that come from, over the course of the lifespan of that person in the system, which emails did they open, which did they not open. Of course, not all that data is necessarily accurate in terms of things like click-throughs, because I've done some exploration, and there are different ways that applications will register something as a click, and frankly, spam engines and spam filters and antiviral technologies will represent as if they're a click, and technically they're not. It's not that the person clicked it, it's that a bot checked it, basically. So some of that stuff is not completely clean, but still it's all in there. And what you guys are now doing, if I understand it correctly, is you're really providing a new layer of transparency that allows organizations to see into that whole data life cycle, right?
Yeah, I think, you talk about clicks, and there's different data sets to understand what your customers or prospects are doing, as example. And the fact is, everyone wants to have an integrated data set where I understand what my customer is, what my products are, what my suppliers are, what my operations are. But that takes work to do. It doesn't automatically fit in. And really, the work that is done is code in the sense of a software development code. And all these people who are in analytics, whether they have the title of a data engineer or a data scientist or even a person who does data visualization, they are producing code. And so what that means to someone who's managed a software team means complexity. And I think of, in my career, looking over a group of people writing code, and I'm scared they're going to create a big hairball of complex code that no one will be able to take care of. So I want that team of people to be able to create and invent and deploy and run their code with as fast as possible. And software analytics is code, and so there's lessons to be learned from how software development has done it in Agile and DevOps, and there's some unique parts to how analytic teams do it. So to answer that simple question of how do I learn more about my customer given all these crazy data sets? Well, it's about putting a team of people who can iterate quickly to be able to get the answer. Because the other part of the heroic journey is that there is no hero who can kind of go into your mind as a business person and pull out exactly what you mean. You've got to show people what it is and let them touch and feel it.
That's right. No, that's a very good point. And, I love, too, just the whole concept of the hero's journey because, frankly, all these movies about heroes are kind of misleading, right? And people want to be the hero, but you don't want to have to be the hero day after day after day after day. So I think that's a very clever approach that you guys take to telling your story. And let's kind of segue into our next guest here who has quite a pedigree in this business. I'm very pleased to have Usama Fayyad of Open Insights, a long-standing colleague of mine. Welcome to DM Radio.
Thank you, Eric. It's good to be here.
Sure thing. So first of all, we can talk about your company, what you're doing now, but I would love the audience to hear a bit about your past because you were at Yahoo a number of years ago and were really at the epicenter of a movement that wound up changing the entire industry of data. So tell us a bit about your history in the space.
Yeah, so unfortunately, my history in the space goes back all the way to the beginning to like 1990. But did my PhD in AI and machine learning in 91, and really got the privilege of working with a lot of scientists who at the time, the scientists at the time, funny enough, were the only ones dealing with large data sets. And I was at NASA's Jet Propulsion Lab and got the chance to work with a lot of scientists in different areas. And the first thing that shocked me was these learning algorithms and data science algorithms were solving problems that in science were considered pretty open problems for a long time. And we were doing it very quickly. And that was an eye-opener because in the science domains, people can spend a whole lifetime studying one data set. So the ability to add value quickly was pretty amazing. That actually transitioned into my move into Microsoft, where primarily had to worry about, well, what does it take to embed, these data mining and machine learning algorithms inside the database, and how to think about it from a server perspective, and how to try to make it mainstream. We've had some good successes embedding it with OLAP and analysis services, and I think SQL Server 2000 had the first time in its history had what came out ahead of its competitors technologically because of those efforts. But then went off and did a couple of startups, the second of which all in data and hosted data and managing data and data science. And the second of which got acquired by Yahoo, where I became the world's actually first chief data officer. And the challenge there, and it's amazing because Yahoo was sort of in a league of its own at the time in terms of trying to get direct monetization out of data and trying to get on top of a lot of data. We were generating something like 25 terabytes of data per day. This is just from people clicking on stuff. And the big thing that happened there is not only were we able to show that monetization is very possible and fairly quickly, but we have to start dealing with some of the issues that we're talking about today, which is how do you run a targeting business at scale, where Yahoo had something like 2,500 categories for targeting, and each of the categories required a model, and each of the models, predictive model, had to be updated. You had to make sure that the inputs to it were healthy and correct, that it wasn't pointing to some old website that changed or some old property that changed its content, etc. So making sure that these models were actually valid, were refreshed properly, etc., was a very, very big challenge to make the targeting business reliable. And this is how we created and scaled the behavioral targeting business. But one of the interesting things that happened at Yahoo is I was also charged not only with running data, but also starting their Yahoo Labs, but also what we call the tech branding of Yahoo. So getting engineers around the world to think of Yahoo as a technology company, not a media company. And an element of that was an attempt to sort of push Yahoo to say, look, you've built the whole business on FreeBSD, which is the free version of Unix, but you're not contributing anything to open source. So we should be contributing something to open source, and that's when the idea of democratizing search technology and releasing search engines that are based on top of Lucene, etc., like Solr, and later going deeper and saying, well, what do you need to do to manage all this data to enable search and indexing and so forth? And that's how Hadoop was created. Hadoop was created as, we thought at the time, a means of democratizing search technology. And I really didn't think more than 10 organizations around the world would really have a use for it. But we thought that it will enable many people to contribute and help us through open source, solve the search problem and try to compete better with Google. And what's funny is a lot of the naive assumptions at the time that we were criticized for in creating Hadoop, namely we relied on commodity storage versus highly specialized high performance storage. We relied on a file system rather than a sophisticated database underneath, and the last one, which is also accidental, we actually created an architecture which required to have a lot of compute nodes attached to the storage machines. And we were criticized heavily in the early days that, hey, for a storage medium, you guys are very expensive in the data center because you have all these unnecessary processors. And what's really funny was to see that every one of those weaknesses turned out to be a huge strength for Hadoop that's today making it, accidentally by the way, the data platform of sort of the new world of big data. So the fact that we used commodity storage actually lets us create storage fabrics that are anywhere from 100 times to 1,000 times cheaper than sort of specialized data warehousing appliances. The fact that we use the file system created so much flexibility that actually enabled a lot of the data science work and a lot of innovative applications that take in unstructured data and so forth to actually happen on a platform. And the last one, I think the market hasn't even realized its value, is the fact that when you have so much compute on top of the storage, even though at the time it looked excessive, now it actually offers a whole new architecture which can avoid one of the biggest sources of messes of data in the enterprise, which is when app engineers create their new app, they typically create their own app database, which creates its own version of the truth, and soon you have tens or hundreds of thousands of these app databases running around, and you no longer know what's real from what's not. Well, here's a platform that says, don't bring the data to the apps, but bring the apps to the data. And that is also extremely transformative. So that's the journey at Yahoo. And after leaving Yahoo, I basically finished sort of my stint 4.5 years as the world's first chief data officer, and went into my own company, Open Insights, where we actually addressed strategy, data strategy problems, how to help companies deal with big data, how to approach the gaps both in technology, in design, and in people, in executives. And then in the middle, I got interrupted by a 325-year-old bank out of London called Barclays that wanted me to join as their global chief data officer. So I had my 3 years at Barclays and then came back and restarted Open Insights and picked up a whole bunch of projects around the world with some large enterprises. So that's where I am today.
Yeah, it's a wonderful history that you have here, and I wanted our audience to get a flavor of that because you have this, let's call it a bird's eye view of where we were, how we got here now, and where we are now. And I think that's the real question to dive into is where are we now, and how can organizations make use of all these new technologies and these new systems and ways of doing things? Because as you know, I'm sure just from your experience with Barclays and other companies, old habits die hard, right? So there are lots of legacy systems out there, and what I kind of see happening with the advent of data science and the assistance of things like data ops is a new caliber of system that is being designed around the legacy, like a superstructure outside and around, but connected to the existing legacy systems that will someday subsume them, but for now is going to be incorporating them, but existing somewhat outside and above the existing infrastructure. But what do you think about that?
Yeah, actually, I fully agree with that characterization. In fact, where we are today is, I would say, we're in the zone of the big data enabling the big mess is my short acronym for it. But basically, where we are is the world, for economic reasons, has discovered that these big data platforms, not only are they capable of doing a lot more in terms of handling a wider range of data and doing it much more easily from a extract, transform, load, etc. perspective, but they actually realize, and this is the primary driver for a CFO in a large organization, if the cost of storage is that much lower. And by the way, I'm not familiar with a single organization around the world that has a diminishing appetite for data. Everybody will tell you, I need more data storage next year than I need this year, whether it's cloud or on-prem. Those factors together basically drove big data into many, many, many organizations, many companies. And these companies, unfortunately, and organizations were not ready for it. And not ready meaning they didn't have the skill set to know how to deal with these new systems and how to exploit them correctly. But more importantly, and this is where the big mess comes in, the technology is so flexible and it removes so many of the quote-unquote constraints and shackles that come with a strictly relational representation of the world that it actually was liberating to a lot of people. But that liberation creates these situations where, it's very easy to create and bring up a data lake where you start dumping all sorts of different data types in it. And soon enough, that data lake turns into what I call a toxic dump, because you've done your quick analysis that was enabled by fusing all these data sets together through this cheap technology that allows you to do this fairly quickly and allows you to do all the acrobatics to create this data lake and all these data transformations. But nobody can effectively reconstruct or understand, or more importantly, govern that data in the data lake. So, we already were challenged in governing, relational and restricted data stores. Now we were faced in something that is, 100 to 1,000 times harder to govern. And govern, by the way, not that we're going to go into that topic today, but this goes all the way from simple stuff like when you define a new attribute, how do you make sure this attribute is not already defined and therefore you're creating redundancy and new versions of the same truth, etc. Actually, that happens in a plethora. But what happens to this toxic dump, this data lake that turned into a toxic dump, is nobody knows what's in it. Nobody dares delete it because everybody's afraid that, it might have some valuable stuff in it, but we don't understand it enough to delete. So it starts existing there and sitting there as, primarily a liability, much more than an asset, after it delivered its quick value enablement. And this sort of brings me to the real topic of today's discussion, which I think is going to be a crucial part of dealing with this whole toxic dump, messy data lake world, which is, machine learning and data science algorithms have a certain view of the world. There's a disconnect between how those algorithms expect the data to look and how they think they can access it, and how that data actually is instantiated in the real world. So that makes the journey of going to training data that you can feed into your data science algorithms a very long, arduous, and really exhausting journey. You need to do a lot of changes, a lot of transformation. You need to do a lot of cleaning. You need to derive many, many new attributes. You need to land on the right representation of that data that makes the problem solvable from a database, from a data science perspective. You need to basically do a lot of normalizations because that data accumulated over time, and over time, the different definitions were changed. Actually, you may have collected data in a certain unit, and then you changed suddenly to another unit, so garbage in, garbage out. If you can actually, you got to detect these things, you got to normalize the data across them so the model doesn't sort of build, or the algorithm doesn't build models over junk. And that leads to a situation where so much handiwork is being done by data scientists who, by coincidence, happen to be some of the highest paid members of the staff in the data world. And these data scientists, they're highly paid, and they end up spending a lot of time doing, basic stuff in data cleaning, in transformations, and they're not the best people in the world in sort of keeping track as to what they've done because they're very, very much guided by sort of delivering towards a goal. So what happens here is, because they're in high demand, not only are they costly, but they actually churn on you fairly quickly, right? It's very hard to keep a data scientist in an organization long term because there's so much demand for their skills on the outside. So what that results in, every time a new data scientist, and this, by the way, happens in startups, it happens in large organizations, big enterprises, every time a new data scientist comes in, can't figure out what the heck was done before, restarts from scratch, and spends again their expensive time doing all the stuff they don't like to do. I've done many studies, and I've actually read many studies that basically say about 90% of the work of a data scientist is spent on effectively non-data science work. This is like having a heart surgeon do a lot of general medicine, right? And this is where, in order to come up with a rational response to this economic quandary, people started saying, well, how do we decompose this problem and start approaching it in a more rational way? And in fact, I love your analogy of DevOps, right? Because DevOps enabled us to go from an age where it would take 3 months to 6 months to a year to sort of deploy a new version of a website or an update, to being able to do 10 to 50 deployments a day without even thinking about it. And that happened by bridging the gap between operations and development, by creating a whole set of tools that effectively allow them to have a healthier and more fact-based conversation. It sort of bridged the gaps between the two cultures and allowed us to bypass a lot of the handoffs where a lot of stuff was misunderstood, as you threw it over the wall from development to deployment. I think the same is much, much needed in the world of data science. And this is basically the beginning of the emergence of the data engineer. People are saying, well, this data scientist is hard to keep with me. They're usually, they have a, with all love and respect, they have a prima donna attitude. So they view their work on, cleansing data and slugging data around as sort of
Right.
not where they want to spend their time. So you try to support them by bringing in the data engineers who are basically wrangling data and cleaning data and sourcing data and figuring out how to fuse it and how to bring it together. And I think that results in a very good partitioning that basically says, look, I'll have the data scientists spend their time on what they really enjoy and what they should be paid highly for. I need to create these specialists who actually, as engineers, begin to understand the vagaries of the data, the issues with the representation, all the things that at the very beginning of the show you mentioned as, an afterthought where people, build data systems as a, support function to an IT project and don't really think hard about the implications of, well, why am I representing the data this way? Is the database architected correctly? Is the data architecture, the right one? Am I using the right data models? Am I standardizing? They don't think about any of that because they think of it as, this is a support function. I just need the app to be up and running. And that actually creates that mess. And I think with the creation of the data engineers, people begin to systematically get an appreciation for, why do you need to have the right data architecture, the right data models, the right standards in data, and the right governance to prevent the mess from happening all over again. And of course, with that, you now need the tools that will allow, as you swap data scientists and as they start to do things like refresh models and so forth, how do you restore, a data science session? How do you bring all the context back together? How do you enable them to retrieve the right versions of the data and the right version of the model and do the right update in the right context? And that becomes a whole management issue, which, exactly companies like Domino Data Labs are thinking about and building tools for, and is really the beginning of sort of creating that data ops equivalent and getting us to mature on the data front, much like we matured on the IT and ops and development front.
Yeah, and that's actually a brilliant segue. You must have been reading my mind because that lets me bring in our final guest of the day who can share with us some information and some perspective on these issues. Nick Elprin of Domino Data Labs. Welcome to DM Radio.
Thanks a lot for having me.
Sure thing. So you know from experience the value of having these data engineers do their job just so that, like with a car metaphor, which Chris gave us earlier in the show, the driver doesn't have to worry about the engine being manufactured and designed properly. The driver can just drive the car. So once all that engineering work is done, then the next person comes into the chain and drives that car, drives the Tesla or whatever the automobile might be. And that's kind of where you guys come into the picture, right? So could you tell our audience a bit about Domino Data Labs, what you guys do and where you got the idea?
Yeah, and I think, and you were right, that Usama's perspective set us, so it was a good, very natural segue or transition to my perspective. So really quickly, my background, I spent a while working at one of the world's biggest hedge funds, Bridgewater Associates, and the relevant part of my background coming from that world was it was an environment where the hedge fund used predictive models and algorithms to drive its investment decisions. And as a result of being in that environment, we had to build very advanced internal technology and platforms to scale and to systemize that process of doing new kinds of research and all the data we had, developing models, and actually operationalizing them to drive investment decisions. And coming out of that environment, I saw, my co-founders and I saw sort of a number of different organizations and industries beginning to make a similar investment in data science, beginning to think about how do we put models at the heart of our business, and how do we use models to improve operational efficiency, or improve our supply chain, or make better product recommendations to customers, or develop new investment strategies, all sorts of use cases. And on that, one thing I would layer into your introduction at the top of the show, where you said, we're scale is the thing that changed. We now have bigger data sets, more data. I agree with all of that, and I would add that the other sort of interesting changes that we're seeing in the world are the dramatically decreasing cost of compute. Cloud compute resources are now several orders of magnitude less than they were a decade ago. And at the same time, the rise of much more powerful, innovative computational techniques to process data to make predictive decisions or recommendations or initiate action. And so the combination of those three factors, the increasing data volumes, the decreasing cost of compute, and the rise of new, more advanced algorithms are leading to this wave of data science. And that is, in the past, if we thought that organizations needed to be data-driven businesses, they were looking at dashboards and BI tools, and they were looking at visualizations to inform humans making decisions. What we're seeing now is the rapid shift towards businesses being model-driven, where they're actually using these algorithms to do what Usama was describing. He did it at Yahoo, to put automated decision-making at the heart of what drives a number of businesses. And our view on that is that enabling that way of working, enabling that way of running a business requires a new set of technical capabilities that are different from just collecting the data, and that are different from sort of the old BI world. Let me pause there and give you a chance to reorient me.
Sure. No, that's a really good foundation to build upon here. So, what's interesting is that we do have this whole new generation of applications that are in the cloud, and there are different architectures, right? So if you think about the difference between an on-prem environment where you've got your data center and you install all your applications and all the hard work and effort that goes into doing that, only to have to update those applications 3 months and 6 months and 9 months later, that's a very different environment. And you're now seeing the cloud as the sort of new normal for where things get deployed. And it makes a lot of sense. It makes a lot of sense from the end user perspective. It makes a lot of sense from the provider perspective. So I'd like to have you maybe comment a bit on how companies need to think differently going forward about leveraging their own superstructure that kind of sits outside but is connected to their existing environment, with the idea being we're really trying to get a stepping stone into the next echelon, if you will, or the next way of doing business with data. What do you think about all that?
Well, I agree the cloud is sort of where the world is moving, and in particular, what we've seen a tremendous amount of success with organizations using the cloud as a first using predictive analytics and sort of data science workloads as first workloads to move into the cloud. And that's because, unlike kind of traditional software development, data science and modeling use cases can benefit from burst compute because they can often be very computationally intensive. So a model training task could benefit from spinning up 100 machines, and that can actually dramatically accelerate the time to do data science work in a way that it might not be able to be that effective for speeding up software development. And the other thing I would say that we're seeing with early successes in the cloud is some of these more modern data science techniques can benefit from specialized hardware compute resources like GPUs. And so that's we're seeing the need for elastic or burst compute and the need for GPUs pull a lot of these organizations into the cloud because they create such a compelling opportunity for some of these data science workloads, even if other parts of the business are remaining or resisting or slower to migrate to the cloud.
Yeah, you bring up a really, really good point here, and you're reminding me that I want to get this across, that part of scalability is elasticity. And what you just mentioned right there is really important because there are certain workloads that are very processor intensive, basically, and there are certain workloads that are not, but require a lot of storage. So if you can scale out as needed to be able to do those as heavy modeling scenarios you talked about, that's good stuff. That enables agility. And I think that the new normal for businesses that want to reach a certain level of scale for their own operations, you must be agile. And it's very difficult for large organizations to be agile for obvious reasons, things like decision trees, things like bureaucracy, et cetera. It just takes a while to get things done. So anywhere that a large organization can get that elasticity, they're going to want it. And I see that as part and parcel to this whole movement of really embracing data ops and DevOps and data science. What do you think?
Yep, I completely agree. And one of the interesting dimensions of that I'll add, when you talk about agility, part of agility is certainly what you were describing, changing how organizations work and dealing with things like bureaucracy. But in the context of data science workloads, one of the things that we spend a lot of time talking with our customers about is to remember that data science is fundamentally, a lot of it is a research endeavor, and that means that experimentation and iteration and testing different ideas is absolutely critical to driving breakthrough ideas. The first 20 or 30 variations of an idea that you try in a data science research process may not work. And one of the things that compute elasticity, compute scalability does with the companies we work with is it enables them to test more ideas faster, and that will accelerate the time to get to really breakthrough research or breakthrough insights that can transform the business. So it's a lot more than just an easier way to deal with IT requests. It is actually something that can be much more accelerative than that. And and then I would layer on top of that the other benefit of elasticity in cloud compute resources is, of course, the cost controls, because if your data science team needs 100 GPU servers, that's a pretty significant capital expenditure outlay. But if you can spin that up for a few hours when you need it and then spin it down when you don't, then you're in a much better spot.
Yeah, that's exactly right. And this is the power of being able to rent the sources that you need, right, and scale up and scale down. In the old data center, well, you had to go out and buy all those machines. And I always hear these great quotes doing these shows. That's why I appreciate talking to folks like yourselves, because you just offer some great perspective. But one of the quotes I heard one time was that in these days, friends don't let friends build data centers, right? Because it's an old way of doing things, and what you really want to be able to do is leverage the multi-cloud environment. And to me, I think that's going to be a big trend going forward. I'm already watching some vendors kind of focus on that space of being able to enable access to Amazon Web Services, the Amazon Cloud S3, for example, for storage, but also Azure, Microsoft Azure, also IBM Bluemix, because they are going to have their different characteristics, whether it be pricing or functionality or agility or ease of use or whatever. And I think the smart organizations are the ones that have cloud architects who are going to be able to map business needs to cloud offerings and understand the difference between Azure and AWS and Bluemix and the HANA Cloud Platform and all that stuff, right? I think that's going to be a really hot job title going into next year as the cloud architect. What do you think?
Yeah, I agree. And the more that, well, I agree with all that. And I would just say, we're seeing increasing interest in people who understand how to utilize those capabilities, not just for sort of generic IT purposes, but specifically for advanced analytic modeling, data science, machine learning tasks.
Yeah. This is great stuff. So, before we get into the roundtable, as you prepare for 2018, what are you guys focused on? What are you going to be rolling out, or what's your main message to customers and prospects entering the new year?
Yeah. Well, we have a vision of what we think of as the data science life cycle, and Usama touched on this, but to really put predictive models at the heart of running your business, you need to both have a team that is well equipped and empowered to rapidly develop those models. Think of it as sort of a laboratory environment where they can test ideas as quickly as possible, taking advantage of scalable compute, elastic compute, things we were just talking about. But they also need a way to then deploy or operationalize those models so they can actually get integrated into business processes rapidly instead of being delayed. There are companies we've talked to that have said, once their data science team develops a model, it can take 9 or 12 months to actually get it over the wall integrated into legacy IT systems. There's an insurance company we work with that joked that they built an entire new building for their organization in less time than it took to get one of their models deployed and operationalized or productionized. So the way we've designed our platform is we support that full life cycle, going from sort of development all the way to deployment. One of the things that we're really excited about in the first half of 2018 is we're going to be providing some ways for sort of executives and business stakeholders who are responsible for the areas that these predictive models are affecting in the business to actually get transparency into what those models are doing, how they're performing, so that it's less of the theme we're hearing more and more from companies at the executive level is, hey, we're spending all this money on data science. We've hired all these expensive data scientists and built these teams up. We're not sure what the ROI of that is. And so because our platform offers a place where all of that work lives and all the models are getting built and deployed, we're actually able to start lighting up or exposing some of that value, and we're pretty excited about that.
Yeah, that's actually a great segue into the roundtable too. So let's go around the room again, and I'll bring in Chris from DataKitchen. ROI is such a difficult thing to determine when you're doing these kinds of projects. You have to make all kinds of assumptions about how much time and effort goes into it, how much money do we spend, how much time do we save, what are the ways that you get that return on investment. But it's crucially important. And I think what we just heard there from Nick is actually very interesting. And there are some other vendors that are kind of focused on this, and I'm guessing that you guys have spent some time thinking about it as well. What is the best way to enable an ROI, taking into consideration everything from time saved to opportunity cost, for example? What do you think about all that?
Well, I think it's interesting. It's really hard to judge a model or a visualization's impact on a business person's decision or a customer's decision to purchase. In reality, it's an attribution is fundamentally a hard problem, and I don't think anyone's really solved that. And the way we touch that elephant is to say, look, we have lots of smart people in analytics, but fundamentally, they don't know what they're doing. We're taking guesses, and we're putting it in front of our customers, whether they're an end customer or business user, and getting feedback about whether it makes sense. And so the way we think about ROI is how fast you can cycle, and how many times you can actually deliver things into production. And so it's almost a manufacturing metric on value. All those people who are creating models or doing data work, can they make a lot of changes? Can they get it into production? And are their number of errors going down? And that's the way we see the people should think about value in analytics.
Yeah, sure.
I think
Go ahead.
Oh, I was going to say, I really like that framing. Yeah, I think that there's a notion of sort of iteration speed or number of iterations or number of revisions that you've made to something that I agree is certainly a proxy for how are things getting better at what speed.
So I think to address this is Usama, to address the ROI question more directly, I actually think there will be a time when we'll need to get a lot more scientific in the attribution. However, I just want to mention to everyone that in these days, I call these the low-hanging fruit days, because there are so many things in an organization, large or small, where you can either significantly cut costs through automation via, some of these data science models and a little bit of AI, or drive so much revenue upside that the little, ROI tracking of all the little costs sort of goes in the noise. And I think that with the projects we've run with Open Insights and with many organizations around the world, that characteristic has been very true, where the ROI is so high that it really wouldn't matter whether you were like plus or minus $1 million on the estimation of the actual cost of doing the activity, because the return is so high, be it in automating manual operations, say in a call center or a data operations center, or increasing revenue by addressing and targeting the right market, by directing the spend to the right areas. So what's working for us in the data science area today is the fact that it is early days. And my advice to everybody is start with the big needle movers. Don't sort of go after the little problems where you'll end up having all these long discussions around, well, did you save me more than you spent? Do it in a space where it's like so transformative that people will say, can you do more for me?
You just gave me a great book title there, Usama. And if you want to write the book before I do, just go ahead and take it. It's called Plus or Minus $1 Million, The Value of Data Science. That's very good.
Happy to be second author with you, Eric.
There you go. Because I think you make an excellent point here, right? You can nitpick about saving $10,000 here, $5,000, or even $100,000, but when you're talking about the scale of big business and how much these data science techniques can help, plus or minus $1 million, hey, who cares? Sooner or later you're talking real money, right? And I think that's an excellent point. That's a good way to kind of close the show and kind of go around the room here, because I view big data as a second chance for data. And what I mean by that is we learned a lot of lessons in the first, let's say, 3 decades or so of machine-managed information assets with data warehousing and business intelligence and all that fun stuff, because at the end of the day, lots of presumptions got baked in there, lots of people had to fudge the numbers to give reports to their board and so on and so forth. But now in this era of big data, especially with machine learning helping us fine-tune decisions and fine-tune processes and automate things, it's going to be harder and harder to not see the actual truth. And so, I think about things like the jobs market. In fact, I'm going to be doing some work in 2018 with one of the big vendors in our space, SAP. They have a whole new branch of their operation called the SAP Data Network, and they've done some amazing things in aggregating and anonymizing transactional data. That's real-world data. So as opposed to like the Bureau of Labor and Statistics, which gives you estimations of how many jobs are in this space or that space, now we're going to be able to see aggregated, anonymized data of exactly precisely how many jobs are in this market, in this particular segment, and so forth. So just 20-second final comments from each of you. Chris Bergh, how are things changing, and how is real-world data going to help?
Well, I guess I've been reading a lot about the limitations of how we think as people and how we're fundamentally irrational. And my hope is that better data and better algorithms can ultimately assist us to being sort of more rational and healthier people.
All right, 20 seconds. Usama, Fayyad, what are your closing thoughts?
Well, my parting thought is this. Take the simplest element that we think of today, the transaction. It went from being how much, where, when, to being where are you going from, where are you going to, are you moving, are you transitioned, what's around you, what's the context, all sorts of other information attached to this transaction. So this is a world of data explosion.
And the final 20 seconds from Nick Elprin, Domino Data Lab.
I think on that particular question, I don't think I'd have anything to add to Chris or Usama. The other perspective I would offer, though, is I think that we're due sometime soon for sort of a misstep as a result of overconfidence or letting these algorithms and models that we're building sort of become so autonomous and create feedback loops that we don't fully understand. And there'll be some sort of moment of unintended consequences or reckoning that we'll have to deal with.
think you're right about that. And with that, we'll bid you farewell, folks. You're listening to DM Radio.